In this video, we're going to be looking at section 3.1, where we begin discussing functions. So the first line we have here is the textbook's definition of a function. It says a function is a relation that associates each element in the domain, which is typically the x values, with exactly one element in the range, which is typically the y values. Alright, so what does that mean? Well, the best explanation I can give you is to think of it like a multiple choice test. If I ask you guys a question, I need everybody to have the same answer. If half the class has one answer, the other half the class has another answer, and you're both right, then that's going to be a problem. We need to have just one correct answer. Alright, so if I ask you for the answer to number 1, everybody should say the same thing. Let's say B. If I ask you for the answer to number 2, we should all have the same answer. Number 3, number 4, and so on. Everybody has to have the same answer. Can they repeat? Of course, because we typically have A, B, C, and D for answers, so they're going to have to repeat. That's alright, as long as everybody has just one correct answer for each question. Alright, so that's the idea for a function. When we plug in a value for x, we all have to get the same value for y, just one value. So let's look at these two examples and see how they work with this idea of functions. So we're starting with our domain, that's our starting values, and our function takes them to another value, which we call the range. So for our first example here, 1 goes to A, 2 goes to B, 3 goes to C, 4 goes to B. And we want to know, is this a function? Well, let's think of it in terms of our multiple choice test. If I ask you the answer to 1, you say A. I ask you the answer to 2, you say B. 3, you say C. 4, you say B. So does everybody have a correct answer for that? Yes, everything is fine. Is it okay that 2 and 4 go to the same place? Yes, as long as each one has its own answer. So for this one, we say yes, this is a function. Now let's look at this one. 1 goes to A, 2 goes to B, 2 goes to C, 3 goes to D. So is this one a function? If I ask you the answer to 1, you say A. If I ask you the answer to 2, well, we've got a problem. Which one do you circle, B or C? Okay, so that's the problem right there. So is this a function? And the answer is no. All right, now, since we don't normally deal with blobs and arrows in math class, we need a way to look at this in terms of the things that we do look at, either equations or graphs. Okay, so one easy way to look at a relation and decide if it's a function or not is something called the vertical line test. This is actually out of section 3.2, but it makes more sense to me to put it here where we're talking about functions. So the vertical line test says a set of points is the graph of a function if and only if every vertical line intersects in at most one spot. Okay, so what that means is as you're going across, typically we go left to right, any vertical line that you could possibly draw cannot intersect in more than one point. It's okay if there's 0, but there can't be more than 1. So one way to do this is to take your pen or pencil and just swipe across from left to right and see if your pen or pencil would intersect in more than one spot. Now I can't do that, so we're going to draw lines. So let's look at this first one. Any vertical line that I could possibly draw, could it possibly intersect in more than one spot? Well, no, we can see as we go along here, no matter where I draw a vertical line, it's only going to intersect in one spot. Even over here, if it starts to look like it's going vertical, these graphs almost never ever go vertical. It would have to be a special case. So even if it looks like it's going vertical, if you were to zoom in, it wouldn't be, and it's still only going to intersect in one spot. Okay, so we only intersect in one spot, so is this a function? We would say yes, it is a function. Okay, next one is a circle. Perfectly good relation, we've looked at these already. Is it a function though? And the answer would be no, because I can draw a vertical line that goes through in two places. And what that means is my vertical line is playing the role of x, okay, so x equals some number, and what happens is, let's say when x is -2, let's say this is -2. When x is -2, I've got a y value here, and I've got a y value here. So that looks like this over here, where we're going to this one and this one, and that's not a function. So we would say no. How about this one over here? I've got no intersection points over here, that's okay. But when I get over here, we've got 2 intersection points, and that's a problem. So this one is also not a function. So that's the vertical line test, is drawing vertical lines through your graph to see if it is or is not a function. Okay, so now that we've established that we do have a function, we can use function notation. And the key to function notation here is that y is going to be the same as f of x. Normally in math, when we have parentheses, it means times, but this is an exception, f of x. Okay, so when you see a function, it's going to have these parentheses and then some value inside of it. Those go together, you cannot take them apart. So let's say we have y is equal to x squared plus 4. This is a function. So we could also write it as f of x equals x squared plus 4. Okay, these mean the same thing. Y equals x squared plus 4 and f of x equals x squared plus 4. Now, why would we want to use function notation? Well, it's more sophisticated. Sometimes when we do things in math, it is a much easier way to track things. So let's say we had let's use these two. So we have y equals x squared plus 4 versus f of x equals x squared plus 4. All right, and let's say we want to know when what value y is when x is different values. So let's say we do x is equal to 2. We would plug that in. We would get y is equal to 2 squared plus 4. So y is equal to 4 plus 4, which is 8. And let's say that we want to do x is equal to 3. So we would plug 3 in. 3 squared plus 4. So that's going to be 9 plus 4 is 13. And let's say we want to do x is equal to 4. So y is equal to 4 squared plus 4. 16 plus 4 is 20. Okay, so this might be what we did before, or we might have set up a table to keep track of our x and y values. Now with function notation, let me draw a little line here to separate them. With function notation, we can do that all in one step. So when x is 2, that's going to go right here, and we're going to say f of 2. What is our function value or our y value when x is 2? And whatever goes inside the parentheses here is going to replace x. So I'm going to replace x with 2. Anywhere that there was an x is now going to become a 2. So I get 2 squared plus 4. 4 plus 4 is 8. All right, so when I plug in 3, now x is going to become 3. So anywhere there was an x is now going to become a 3. 9 plus 4 is 13. And f of 4, anywhere there was an x, it's now going to become a 4. And I get 4 squared plus 4, 16 plus 4 is 20. So you can see we get the same numbers, okay, 2 and 8, 3 and 13, 4 and 20. But over here, when I look at this, I know this is my x value and this is my function value or my y value because they're the same thing. So I know when x is 3, y is 13. When x is 4, y is 20. So it's just a little bit more sophisticated as far as record keeping and as far as being able to look at somebody else's work and know exactly what they were doing. All right, now let's go back to f of x is equal to x squared plus 4. So we can plug in numbers. It looks just like this. One way that function notation is different from x and y notation is that we can also plug in other variables. So if, let's say we're talking about things in terms of x here, but maybe we want to talk about acceleration for a, but we want the same function. We could also have this function in terms of a. So all of the x's would become a. So we'd have f of a is equal to a squared plus 4. Same function, just a different letter. We could also do something like f of x plus 2. Now this one seems a little strange because we're trading x for something with an x. So it seems a little weird, but just remember, whatever was here is going to become whatever is here. So x is going to become x plus 2. This is a substitution. So x is going to become x plus 2. Okay, you see that? So x squared becomes x plus 2 squared. X becomes x plus 2. And then if you need to neaten that up a little bit, you can. Usually the book wants you to multiply these out, so we'll stick with that pattern. And remember, when you multiply out an exponent, it doesn't distribute. You have to multiply it out in FOIL. So we're going to get x squared plus 4x plus 4 right here. So we get x squared plus 4x plus 8 for our final answer.